Hello, and welcome back to your virtual geometry class. Okay, we're going to use two highlighters today. If you want to go ahead and grab your highlighters. Let's go back to the pocket page and grab the paper that you printed on Tuesday. This was the right side of the assignment from Tuesday. If you lost it, you'll have to go back and reprint that document. Okay, this is 10.5, secant lines and segments. Go ahead and title and number your page. It's page 112. On page 113, you did the whiteboard practice on inscribed quadrilaterals. Okay, so we're kind of jumping around the notebook because I already sent this out and 112 was right there. So we just did the whiteboards inscribed quadrilateral practice on 113. And you should have your work written there. I already posted the solutions so you can check your answers. Okay, just zooming in on this. Okay, so two secants. Remember, the secant line goes through the circle twice. So this line AC goes through the circle twice. Same for BD. So that's what makes it a secant. So you have it in words right here. If two secants, or chords, intersect inside a circle, then the measure of the angle formed, so these angles formed by their intersection, is half the sum of the measures of the intersected arcs. So we're just going to write that as a formula. So let's look at angle 1. Angle 1 is right here. Its intersected arcs are the arcs that the angle opens up to. So on this side, angle 1 opens up to arc AD. And on the other side of angle 1, its vertical angle opens up to arc BC. So to be able to figure out the measure of angle 1, we'll do 1/2 the sum of the measures of the arcs. So the measure of arc AD plus the measure of arc BC. So that will give you the actual angle measure for angle 1. Very similar idea for angle number 2. It's just instead of the angle being on the left and right, the angle is on the top of the intersecting secants. So now we're looking at the arcs that angle 2 opens up to. So arc AB. And on the other side of angle 2 would be this arc CD. So just make sure you realize that the intersected arcs are the ones that are across from the angle. The angle opens up to the arc AB. And on the other side of angle 2 is arc CD. So if we wanted to figure out the measure of angle 2, we would do 1/2 of the sum of the arcs AB, the measure of arc AB, plus the measure of arc CD. So same thing, they're just showing you two different scenarios. Angle 1 is when the angle is on the left or the right. Angle 2 is if the angle is on the top or the bottom. So Exact same thing, just using their corresponding arcs. Okay, so I will again do the odds, and then you guys will do the evens, submit them, I'll check them, see what's going wrong, what's going right, and we'll basically build our practice off of that. So this will be due Monday, since I'm posting it today on Friday. I want to give you a full school day to be able to work on this, because I know you guys have a lot going on right now. So, okay, number 1, we want to find the measure of angle AED. So remember, these letters tell you the order to read the angle. We're going from A to E to D. That is this angle right here. So we want to figure out that angle measure, and we just learned we have intersecting chords or secants. It's the same idea, that the angle is half of the sum of its intercepted arcs. So this one's nice and straightforward because they actually gave us the arcs that the angle opens up to. Right here we have the angle opening up to 45, and on the other side of the angle, its vertical angle opens up to 109. So to figure out the angle measure, we just need to find half of the sum of the arcs. So this arc AD plus arc BC. So that is half of 45 plus 109. So we need to find half of 154, which is 77 degrees. Not too bad when they are asking for the angle and they give you the intercepted arcs. Number 2 is very similar, except now it's secants. But again, it's the same idea if it was chords or secants. They're asking for STR, from S to T to R, this angle here, and they gave you the intercepted arcs. So very similar to number 1. Okay, let's add a couple more steps on number 3. So number 3 is a little bit trickier. Notice we want to find the measure of an arc this time. This equation is set up to give us the measure of an angle. So we'll have to manipulate that, move that around. They want the measure of arc QT. So this arc here. So that means we need one of these angles, the angles that open up to that arc. And then across from those yellow angles, we do have the other arc, which is 95 degrees. So before we can find the arc measure, we first need to figure out that angle measure. What should we do to figure out the measure of that angle, the yellow angle? Okay, good. So notice that this is a straight line. And all the way back to the beginning of the year, we learned about supplementary angles. Straight lines make 180 degrees. So if I know that this angle is 79, then I know that this angle is going to be 180 minus 79. So that would make the yellow angles 101 degrees. Okay, so now that we know that angle measure, it will let us solve for the arc measure. We know that that angle, 101, is equal to half of the sum of its intercepted arcs. So that 101 opens up to this 95. And we're going to put an x here to represent QT. We need to solve for x. So 101 is going to equal half of x plus 95. This is using the exact same setup we did on number 1. It's the same concept, the geometric concept, that the angle equals half of the sum of its arcs. So now we just need to do a little bit of algebra, get rid of this 1/2, and then we can solve for x. So two options: you could distribute the 1/2 to both the x and the 95, but then you'll stay with a fraction the whole time. I would rather get rid of the fraction. Remember, fractions are division, so to get rid of it, we will multiply. This says divided by 2, so the opposite of that is multiplying by 2. So I'm going to multiply the other side by 2. Now the fraction is gone. Yay! So 101 times 2 is 202. And now all we have left on the right is x plus 95. Solving for x, just subtract the 95 over. And we get x equals 107. So since x was on QT, that means the measure of QT is 107 degrees. For number 4, you're going to start right here. Number 4 gives you the angle you need already, so you do not have to do this 180 business. They give you the angle 62, and you're looking for the arc LK. So that is right across from 62, so you don't have to subtract from 180. You already have the angle. Okay? So that 62 would go right here. And then you could put an X for LK. Solve for X. Okay, so that is when you are adding the arcs together and dividing by 2, half of the sum of the arcs. So whenever you have the secants intersecting. Now we're going to look at when the secants are not intersecting. So these are 3 different scenarios, and they all have very similar formulas. It's just, if you notice, the arcs are gradually getting bigger and bigger. So all of these scenarios are very similar formulas. They just look kind of different. Now, I didn't have enough space to put very many practice problems on this paper, so I'm thinking probably Tuesday I'll post more of these types of problems so you can practice different scenarios. Okay, so in the words, if secants and or tangents, okay, intersect on the exterior of a circle, so now they're intersecting on the outside instead of the inside, then the measure of the angle formed, so this angle formed by those lines, is equal to half the difference of the intercepted arcs. So instead of adding, we are going to be subtracting. So for the measure of angle A is out here where all of these lines, these secants, these tangents are intersecting. So that is the angle the formula is set up for. The measure of angle A is going to equal half the difference of the arcs. So you need to be a little bit more careful with how you set this up. Always think of it as half of big arc minus small arc. We have to put the big one first because you can't end up with a negative number. You can't do small minus big because then you'll have a negative measure for your angle. You have to do big minus small. So the big arc is going to be on the outside of the circle. So this is arc CE. Measure of arc CE minus the little arc, arc BD, the measure of BD. So you will subtract these arc measurements and divide by 2 to figure out what that angle is equal to. That's if there's two secants. If there's a secant and a tangent, it's the same idea. It's just now this arc is getting a little bit bigger on the outside. So always doing big minus small. Whatever this measure is, the pink one, minus the yellow. And then divide it by 2. Half measure of the big arc is BD minus measure of the little arc BC. So same idea, we're just subtracting the arcs from each other and dividing by 2. Now if you have two tangents, again, all that means is your big arc is getting bigger. So this is now our big arc from B to D to C. So angle A will be half. Now I have to use 3 letters since this is a major arc. Measure of BDC minus the measure of the little arc minus the measure of arc BC. So all very similar concepts. Just subtract the big arc from the little arc that is within these secants and tangent lines, and then divide it by 2, and that will give you that angle on the outside where the lines are intersecting. The way that I memorize the difference between the top problems and the bottom problems is that this intersects and it looks like a plus sign. Adding, you're going to add those. And then these, you can kind of squish it down and make a minus sign. You're subtracting these. So if you squish the secants and the tangents together, it'll make a minus. And these secants intersect, makes a plus. So the formulas are super similar, just this one is a plus sign and this one is a minus sign. All right, number 5, almost done. You're making it through the video. Yay, good job. Good job. Okay, the measure of KLM, angle KLM. So that is from K to L to M. So that is the angle right here formed by the secant lines. So whenever I have secant lines, I know that these are going to squish into a minus sign. Yay. We're going to take the big arc, subtract it from, we'll subtract the little arc from the big arc, and then divide by 2. Angle KLM equals half of arc JN minus arc KM. So we need to do half of 140 minus 66. So doing PEMDAS, do what's in the parentheses first, half of 74. And that means that angle measure is going to be 37 degrees. Super similar on number 6. I just wanted the angle and it gave you the arcs. Again, I wasn't able to fit a lot on this page, so I will post more practice on this. I'm thinking Tuesday. Okay, that was everything. Let me know if you have questions. Send me a message on Edsby. I will host a Zoom on Monday before this assignment is due. Log into that, tune in. If you have any questions that you would like to ask, if you have any problems you would like to work out together. Okay, see you soon.